In Chapter 7, we're going to factor, which is basically the opposite of what we did in Chapter 6. In Chapter 6, we took two factors, multiplied them, and got the answer. Now what we're going to do is we'll have the answer and break it down into the factors. So the first thing we're going to do is just find the greatest common factor, or the GFC. And the greatest common factor is the largest number, or, well, this is for numbers, the largest thing, I'm just going to say, that will evenly divide into all terms. So basically the largest term that will evenly divide into all the terms. So to start out with numbers, let's say we have 6, 3, and 12. 3 is the smallest number here, so we're going to start with that. 3 will divide into 6, it'll obviously divide into 3, and it will divide into 12, so the answer here is 3. That's going to be the greatest common factor. If you have something like 22 and 23, the greatest common factor is just going to be 1, because that's the biggest number that will divide into both of them. Then let's say you have some bigger numbers, say 48 and 72. So there are a few ways that we can do this. One way is by doing a factor tree. And so what we'll do here, and that's going to be like we did at the beginning of the class, where we found the prime factors. And so we're going to 2 will go into 48, and it'll go 24 times. And then 2 will go into 24. It'll go 12 times. 2 will go into 12 6 times, and 2 will go into 6 3 times. So this is the prime factorization. 2 times 2 times 2 times 2 times 3. For 72, 2 will go into it 36 times. 2 will go into that 18 times. 2 will go into 18 9 times. 2 will not go into 9, but not 3 will. So, and, oops, 3's. And it will go into 9 3 times. So 2 times 2 times 2 times 3 times 3 are the factors of 72. Then what we're going to do is look to see what is in both of them. So we have a 2 and a 2, a 2, a 2, a 2, a 2, and a 3, and a 3. So we just have to find what's common. So 2 times 2 times 2 times 3, which is 24. So 24 is the greatest common factor of 48 and 72. Now that's one way to do it. Another way that is sometimes easier is you have the two numbers and you start with the smallest one. Will 48 go into 72? No, it won't. So then you divide 48 by 2, which is 24, and will 24 go into 72? It'll go 3 times, so that makes 24 the greatest common factor. If that didn't go, then you would divide the smallest number by 3 and see if that one works, and so on. Okay, so I'm going to do one with 3 numbers. We have 18, 42, and 84. So I'm going to first do this with the factor tree. So 2 will go into 18 9 times, and then that's going to be 3 times 3. 2 will go into 42 21 times. 2 won't go there, but 3 will. And it goes in 7 times. 7 is a prime number, so that's where we stop. 2 will go into 84 42 times, and then 2 will go into 42 21, and then 3 7. So now we have to find what's in common of all of them. We have a 2, a 2, a 2. We have a 3, a 3, a 3. We have another 3 here, but that's not in both of these. And we have a 7 here, but that's not in both of those, so we can't do that. So 2 times 3, which equals 6. 6 is the greatest common factor of these 3 numbers. If we want to do it the other way, we have 18, 42, and 84. Now here, we just need to see if the number will go into, we have to go in to see if they'll go into everything. So we'll start with 18. 18 will not go into 42. We don't need to worry about if it'll go into 84, since it won't go into 42. Then divide this by 18 by 2, which is 9. 9 won't go into 42, so we know that 9 isn't right. Then we'll divide 18 by 3, which is 6. 6 will go into 42 7 times. It'll go into 84 14 times. So 6 is the answer. So usually this way can be faster. You just have to remember, start with the smallest number, see if that number itself will go into it, because remember 6, 3, and 12, 3 went into everything, so we were able to use that. And then you divide it by 2 and see if that number will go into everything. Then you divide the smallest number by 3, see if that will go into everything. Then you divide it by 4, see if that will go into everything. Then divide it by 5, see if that will go into everything. You may eventually, especially if you have big numbers, you may get all the way down to a smaller one, so that the factor tree may have been the quicker way to do it. It all depends on what you're given. So the next thing is the greatest common factor of terms where there's the variable part. So for this, greatest common factor of terms for just the variable part, and this part is even easier. For these, it is the one with the smallest exponent. So on these, you can just look at them and get the answer. So here, say we have x, x squared, and x to the 27. This is x to the 1, x to the 2, and x to the 27. The answer here is just going to be x, because it has the smallest exponent. If we have x to the 4, x to the 7, and x to the 3, we just need to see which one of these has the smallest. We have a 4, a 7, and a 3. 3 is the smallest, so the greatest common factor of these is x to the 3. That's all you have to do when it's the variable part of it, is just look for the one that has the smallest variable, but you do need to keep the variable and, or the smallest exponent. You have to keep the variable and the exponent. So now let's combine numbers or terms with both coefficients and variables and negatives. So if we have a -1, that can be a factor. Sometimes you will have to factor out a -1. We're going to see that when the leading term has a negative, because we're not going to want it to be a negative number. So it may say to always factor out a -1. It may not. If it says to, make sure you do. But in future sections, you're always going to have to factor out the -1 if there's a negative. So let's just look at 3 terms. 63x squared, 21x, and 111x to the 4. So I'm going to do the exponent part first, or the variable part first. So what we're going to do is look at them. We have x to the 2, x to the 1, and x to the 4. So here, just x to the 1 is the greatest common factor, because x will go into x squared and it will go into x4. So now what I'm going to do is, for these ones, I'm going to do the factor tree. So 2 won't go into 63, but 3 will, and it will go 21 times. And then we've already done that. That's 3 and 7. So here, 3 and 7. 2 won't go into 111, but 3 will, and it will go 37 times. And 37 is also a prime number. So the only number that we have in common of all these is 3. So our greatest common factor here is going to be 3x. We can divide all of these by 3x and get an answer. Okay, let's look at one that has x's and y's. 24x y to the 3 and 84 x squared y squared. So first, I'm just going to look at the variables. So we have x to the 1 and x squared. So it's going to be x to the 1, or just x, as the x part of it. For y's, we have y to the 3 and y squared. A 2 is smaller than a 2 is smaller than a 3. So the part here is going to be y squared. So now we have to find the number that's the smallest that will go into both of these. So this time, I'm going to do it the other method, where I see if 24 will go into 84. It will not go evenly, so I'm going to divide 24 by 2 and get 12. 12 will go into 84 7 times, so the answer here is going to be 12. So 12xy squared is the greatest common factor of these two terms. Okay, so you're going to get a bunch of questions where it just says, what is the greatest common factor? But then you're going to get some that say, factor out the greatest common factor. Now here, they don't want just the greatest common factor. They want you to put all the factors that still exist. So, for example, let's say we have 10x plus 25. What number will divide into both of these numbers? So first off, we just have one that has an x. So we don't have to worry about factoring out any variables. But a number that will go into these both is 5. Okay, so we're going to put the 5, and then in parentheses, now we're going to figure out 10x divided by 5 is 2x. We have a plus. 25 divided by 5 is 5. So our answer here is 5 times 2x plus 5. Now what I did, I found the greatest common factor, which is 5. And then I did 10x divided by 5 equals 2x, and 25 divided by 5 equals 5. That's what we're doing when we're factoring something out, is we're dividing every single term by the greatest common factor. The greatest common factor is going to be on the outside of the parentheses, and what's inside is what we have left. Okay, so the next one, let's say we have x to the 4 minus x to the 9. So here, this one's easy. We just need to find the one that has the smallest exponent, which is x to the 4. So we're going to factor out x to the 4. And what we're doing is x to the 4 divided by x to the 4, which equals 1. And then we have minus x to the 9 divided by x to the 4, which is x to the 9 minus 4, which is x to the 5. So our answer is x to the 4 times 1 minus x to the 5. You're going to get to where you don't do this actual step here. You're just going to say, you're just going to divide it. X to the 4 divided by x to the 4 is 1. X to the 9 divided by x to the 4 is x to the 5. Okay, so let's say we have x y to the 3 minus 11 y to the 3. So what do both of these have in common? A y to the 3. Okay, when we divide this by y to the 3, all we're going to be left with is x. When we divide this term, all we're going to be left with is the negative 11. Okay, so now let's look at a little one that has more terms. Let's say we have negative 10x to the 3 plus 8x squared minus 2x. Now here, we do want to factor out the negative. So I'm going to factor out the negative to begin with, because we just don't want our leading term to have a negative sign. Then I'm going to look at the numbers. We have a 10, an 8, and a 2. The biggest number that will go into all of these is a 2. And now we're going to look at the x's. We have 1 raised to the 3, 1 raised to the 2, 1 raised to the 1. So the one with just the 1 is the smallest number. So negative 10 x to the 3 divided by negative 2x is 5x squared. 8x squared divided by negative 2x is minus 4x. And negative 2x divided by negative 2x is plus 1. So here, when I factored out the greatest common factor, I have negative 2x times, in parentheses, 5x squared minus 4x plus 1. Okay, so the next part of this is going to be a little bit more. It's what's called factoring by grouping. But the first ones they're going to give you are just something like 7, and then in parentheses, x plus 2, and then plus y, in parentheses, x plus 2. So the first term, because we have the multiplication here, and this is all in parentheses, is 7 times x plus 2. The second term is y times x plus 2. So what we're going to look at is what's in parentheses. If they're exactly the same, which they are here, then we can factor that out. So factor out x plus 2. Okay, now, what are we left with? What we did was we divided both of these terms by x plus 2. So the x plus 2's are gone. What we're left with is the 7 and a plus y. So this will also be in parentheses, and it'll be 7 plus y. Now, if you want to see if this is correct, what you can do is do the, if we do this, not quite with the FOIL, because we're not doing the full by grouping, but if we did the distributive, where we distributed the 7 and the y, this is what we would have. So what we're going to do is, we're going to look to see what's in parentheses. If they're exactly the same, then we're going to leave whatever, we're going to factor that out, that's one factor, and whatever's left, including the sign, is going to be the other factor. So I want to show you one here. Let's say we have 3x plus 1 minus, in parentheses, x plus 1. Okay, so remember that if we don't have anything in front of it, that there is actually a 1 here. So let's just draw or write our little 1 here. Even though it's not shown, it is there. So, because there are 3 x plus 1's minus 1 x plus 1 here. There are 3 times here and just one of them here. So now we can factor out the x plus 1, and we're left here with 3 minus 1. Now, on something like this, this number here, instead of a 3, will probably be a y or something. I just wanted to show you that if there's nothing in front of the parentheses, that there is actually a 1 here. Okay, so knowing that we can do that, what we're going to do is factor by grouping. What I just did was actually the last part of factoring by grouping. When we do factoring by grouping, it's going to be when there are 4 terms. So let's say we have xy plus 7x plus 2y plus 14. Now the first thing we're going to do is separate this into 2 binomials. So do this. Put parentheses around the first 2 and parentheses around the second 2. And then what we're going to do is factor what we can out of this one, of this binomial, and then factor what we can out of the second binomial. So we're going to factor an x here. When we do that, we're left with a y plus 7. Then here, we can factor out a plus 2, and we're left with y plus 7. Now, is what's in parentheses exactly the same as each other? Yes, so we can factor that out, which is y plus 7. And then open our parentheses again. What do we have left? We have an x and we have a plus 2. And this is our factor. Now if we want to check on this point, we can do the FOIL. So y times x is xy. Y times 2 is plus 2y. Then inner, 7 times x. And outer, or last, is 7 times 2. Now here, we can rearrange these middle two. We have an xy, xy, plus 2y, plus 2y, plus 7x, plus 7x, plus 14, plus 14. So we know we got it right. Okay, so let's say we have 3x squared plus 4xy plus 3x plus 4y. Now here, if we look at these first two, we can factor something out. If we look at these next two, there's nothing we can factor out. We can factor out a 1 if we want, or we can rearrange them. I'm going to do it both ways. First, I'm just going to factor out a 1 and see if we get something. So on these two, we can factor out an x, and we're left with 3x plus 4y plus 1 times 3x plus 4y. Okay, what's inside parentheses is exactly the same. So we have 3x plus 4y, and what we're left with is x plus 1. Okay, so these are our two factors. Now, if you feel like you have to factor something out, you can rearrange these. So I'm going to flip these two around. So I'm going to change it to be 3x squared plus 3x plus 4xy plus 4y. Now on this, I can factor out a 3x, and I'm left with x plus 1. On this one, I can factor out a 4y, and I'm left with x plus 1. And what I have exactly the same thing in the parentheses, which is x plus 1. And I'm left with a 3x plus 4y. Which is the same that I got this way. Okay, so let's do 4x to the 3 plus x minus 20x squared minus 5. So on the first two, I can factor out an x. When I divide 4x to the 3 by x, I'm left with 4x squared. When I divide x by x, it's plus 1. Now remember when I said factor out a negative. If this middle term is a negative, factor that out. So minus, and I can factor out a 5 from both of these. When I do that, negative 20x squared divided by negative 5 is 4x squared. And then negative 5 divided by negative 5 is plus 1. If you don't factor out the negative, what you would have is x, 4x squared plus 1 plus 5 negative 4x squared minus 1. And they're not exactly the same as each other. You want these to be exactly the same, so that's why you factor out this negative. So we can factor out the 4x squared plus 1. And what are we left with? We're left with x minus 5. So these are our two factors. Okay? So let's say now that we have 3xy minus 4 plus x minus 12y. This one, there's nothing that we can factor out of these two or these two, so I have to rearrange these. So I'm going to rearrange these middle two. So I have 3xy plus x minus 4 minus 12y. Now I can factor out an x here. Actually, I'm going to also, if you notice, we have a 3, this has a 3. This is times 1. This 4 is smaller than this one, the 12. So I'm also going to rearrange these two. So I'm going to have a 3xy plus x minus 12y minus 4. Because I want the bigger term first on both sets. Or I could have done x plus 3xy and then minus 4 minus 12y. But here I can factor out an x, and I'm left with 3y plus 1. Here I need to factor out a negative 4, and I'm left with 3y plus 1. Factor out the 3y plus 1, and I'm left with x minus 4. Okay, so sometimes you will have to rearrange them so that they will work. Okay, so let's look at this. 2x minus 2 plus x to the 3 minus 3x squared. Okay, so on the first two, I can factor out a 2, and I'm left with x minus 1. On these, I can factor out a plus, because this one, middle one's a plus, x squared, and I'm left with x minus 3. Okay, so is what's in parentheses here exactly the same as the second one? No, it's not. So this one cannot be factored by grouping. I'm not going to be able to rearrange them like I did that last one so that I could factor it by grouping. So sometimes you won't be able to factor by grouping. And that's if what you have in parentheses are not the same as each other. Okay? So let's say we have x squared y plus 9y plus 2x squared plus 18. So on the first two, I can factor out a y, and I'm left with x squared plus 9. On the second two, I can factor out a 2, and I'm left with x squared plus 9. The x squared plus 9s are the same as each other, so I can factor that out, and I'm left with a y plus 2. And then that's it. Okay, so let's say that you have something like this. 4x times x minus 6 plus 11, 6 minus x. Okay, so it's already partly factored, but are what is inside the parentheses exactly the same as each other? No, but if you notice, this is an x and a 6. This is a 6, x minus 6, 6 minus x. Here the x is positive, here it's negative, here the 6 is negative, and here the 6 is positive. So they're exact opposites of each other. So here I can factor out a negative 1 of just these two. So what I'm going to do is 4x, x minus 6 plus 11. And I'm going to factor out a negative 1, and I'm left with a negative 6 plus x. So I divided 6 by negative 1, got negative 6, divided negative x by negative 1, and got positive x. Now I'm going to rearrange these two. 4x, x minus 6, plus 11, negative 1, x minus 6. All I did was switch the places of these. Now, I'm going to multiply this 11 by the negative 1. So I'm going to have 4x, x minus 6, minus 11, x minus 6. All I did was rearrange. I used the property that said that I can multiply the numbers in any order I want. So now I have x minus 6 in both parentheses, so I can factor out x minus 6, and I'm left with 4x minus 11. So this is one that's a little bit tricky. If you get something like this, where it's already factored, and you have x minus 6, like basically a minus b and b minus a, you can rearrange those by factoring out a negative from one of those.